Okay, today we're talking about roots of real numbers. Later on in this unit, we're going to be talking about roots of numbers that are not real or imaginary. So we're going to start with some vocab. This number right in front is just like a number in front of a variable. So that's a coefficient. This little number here is called an index. That number tells you what root to take. If you don't see an index, it's implied to be 2. So you'd be taking the square root of something. The symbol is a radical. And whatever's underneath the radical is called a radicand. Make sure you write that down. That's some important vocabulary there. So we're going to get into simplifying, and we're going to start off with just a straightforward one. We're going to take the square root of x squared. And so you'll notice that there is no index, so it's implied to be 2. So again, we're taking the square root. And so what I would recommend doing at first is just to write this out. So I'm going to take this square root. Another way of writing x squared is really x times x. And so this procedure that I'm going to be talking about, it really has to do with the index. Since the index is 2, we're going to look for pairs of 2. And if you find a pair of 2, which there are, we're going to bring one of those outside of the radical. And that's what winds up being the answer. So the square root of x squared is x. Following that same procedure, you'll notice in this example that the index is 3. And so I'm just going to rewrite this. And instead of 8, I'm going to write it as 2 times 2 times 2. Instead of x cubed, I'm going to do x times x times x. I'm going to write y out 9 times. And let's say we wrote out z 21 times. Z 21 times. Hopefully you'll kind of get the idea of how this is going to work. So our index is 3, and what I'm going to do is look for groups of 3. Okay, groups of 3 of the same exact term. So we can see there's one group here, and the way it works is I'm going to take out one of those and pull them outside of the radical. So I see one group of 3 in the x's. I'm going to pull out one of those. I see 3 groups of 3 in the y's. There's 1, there's 2, and there's 3. So for each one, I'm going to pull out one of those y's. So outside of the radical, we're going to end up with y cubed, or y to the third power. If we did in fact write out z 21 times, you'll see that there are 7 groups of 3. So that means we would take out 7 z's, or z to the 7th power. And so what we're left with is 2 times x times y to the third power times z to the 7th power. Go ahead and try number 3 on your own. Here's number 4. And so it's the same idea. I'm just going to rewrite this. And this is going to be x plus 3 times x plus 3. We've talked about that before, how if I have a binomial raised to the second power, that's the same thing as the binomial times itself. So if I take the square root, you'll see that I have a pair of them. The index is 2. And so I'm going to pull one of those out of the radical. And so the answer becomes x plus 3. Here's number 5. And what I'd like to show you is if you try to type this in your calculator. So I'm going to go to second x squared. That's how to pull up the radical sign. negative 36, enter, you'll see that we have an error. The reason is because I'm trying to take the square root of a negative number, and for that one, there is in fact no real solution. And we're certainly going to be getting into this a little bit later in this chapter, but for now, just know that if I'm taking the square root and I have a negative, then it's no real solution. However, for this one, if I pull up the calculator again, I just want to show you how to put in the cubed root of negative 8. So I'm going to clear that out. And the cubed root is under the math menu. So go to math. Cubed root is choice 4. And I'm going to type in negative 8. You'll see that there is in fact a solution here. And that's because negative 2 times negative 2 times negative 2 is negative 8. So we can take the cubed root of a negative number and still get a real solution. So the answer here would be negative 2. Go ahead and try number 7 on your own. And I have one more to show you, that's number 8. If you're taking the square root of a fraction, that would be the same thing as taking the square root of the numerator over the square root of the denominator. And then you're going to take each individually. Again, you can go ahead and type in the square root of 4 in your calculator, and you'll get 2. And if you type in the square root of 25 in your calculator, you'll get 5. We are going to get a lot more in depth with simplifying radicals, but this is just an introduction. See you tomorrow.